time t equals 2, the position of the particle is 0. Find the minimum acceleration of the particle. To find the minimum acceleration, what must I first find? The acceleration. I don't even have acceleration to talk about a minimum, right? So acceleration is, what is that? Oh, good. Look, what's Kit doing there?
He's
Good. Go ahead and make that easy, right? So the original function is 3t squared minus 12t plus 9. So the acceleration is 6t minus 12. Now what? Find the derivative of acceleration. Hey, why do I not do a sign chart with acceleration?
because that would give you the minimum velocity.
That would give me the minimum velocity, not the minimum acceleration, correct? Well, what is the derivative of acceleration? 6. Okay. So let me back that up a little bit. Remember, if you have a function, to find the minimum of that function, you have to take the derivative of it. So having the velocity function, first I had to find the acceleration function, then go from there. This really gets tricky because the acceleration is a constant, which means it doesn't equal 0. So where would I look for minimum values on a constant function? Endpoints. Because I know that it's not anywhere in the middle, it's just constant acceleration. So constant. So I'm going to look at the endpoints. What are the endpoints? 0 and 5. And you could probably imagine, since this is a positive slope, 0 is going to be where the minimum is because we're going up from there. But I'm going to find A of 0 and A of 5. On my work, if this did say justify, it doesn't. But if it did, I probably would say something like that doesn't equal 0. So let the reader know I checked for critical points and there weren't any. I'm going to find A of 0, which is negative 12. A of 5, which is 30 minus 12, or 18. So the minimum acceleration is negative 12. Do we have units? No. Why not 0? Why is the answer negative 12 and not 0? Actually, the minimum acceleration, not where the minimum acceleration happens at. That's why I would put negative 12. Find the total distance traveled by the particle. I have velocity. How am I going to get total distance from velocity? Absolute value, velocity function, and integrate that. Did it say over the first 5 seconds?
Absolute value function.
Right. Now, where this appears to be a by-hand problem, do you agree? So, I'm going to work this by hand. This is a tough problem by hand. It's actually easy with a calculator, but it's tough by hand. So let's look at what we're going to do with that. I know the velocity function is 3t squared minus 12t plus 9. And that's not a problem to integrate it, but it is a problem to think about absolute values in my head. In fact, I don't and then positive after that. It's a parabola. Get better. Right? It's a parabola with positive coefficient. You probably could have graphed that without maybe quite the thought process. So here's what I'm going to do. Now remember, we're only going from 0, right? 0 to 1. I'm going to do multiple intervals because I can't do this in my head. I can't do absolute value in my head. What I can do in my head is the integral from 0 to 1. And then I'm going to add the opposite of the integral. Why am I going to do the opposite of the integral on the next piece? Because it's negative and I don't want it to be negative. From 1 to 3. And I'm going to add the integral from 3 to 5. So formulas are awesome, like that absolute value thing, but they are no replacement for kind of understanding what's happening here. We want the positive distance traveled. We don't want negative distance. So I did have to do some work on this one. If this is a calculator problem, this is a 2-second problem. You type in your calculator, the absolute value bars, and you're good to go. But without a calculator, this becomes a very difficult problem. Now, I'm going to anti-differentiate. So I get t cubed minus 6t squared plus 9t. I'm going to still that work 3 times, right? I'm going to use that same thing from 0 to 1, 1 to 3, and from 3 to 5. If I plug in 1, I get 1 minus 6 plus 9, so negative 6 plus 9, or 30. Open the 1 to 4. Right? 4. Minus 0. Minus. I'm going to plug in 3. 27 minus 54, which is negative 27 plus 0. If I plug in 3, do I get 0? Well, 27 minus 54 plus 27. And I already know if I plug in 1, I get 4, so I get to cheat a little. How do I know I get 4 if I plug in 1? Same thing over there, the only one I have to plug in stuff. I don't really know if this is completely a non-calculator problem or not. I don't know. Like, really make me do this without a calculator. I could look it up. But I needed to teach you how to do it without a calculator. This is the one I can do without a calculator, so. 125. 25 times 6. That's 150. Is that right?
Yeah.
So 125 minus 150 is negative 25 plus 45 is 20. Is that good? Minus 0. So the 4 minus negative 4 is actually plus 4, so 28. Now, perfectly good answer, 28 feet, meters, miles. You would, this problem didn't give us units. Otherwise, you definitely wanted you. Not if there's not a unit. Now, would they give you a point for writing units if there were units? Maybe. So if this did have feet up as a problem somewhere and you said feet, that may be a point just putting the feet. So we talked about that in fall, didn't we? Sometimes you just get unit points. Okay, this is the way to do this with integrals. I want to stop and remind you, you actually did this the derivatives in the fall. So this is one option for the work. I want to show you the other option. You do not need both options. One or the other works great. Does anyone remember in the fall how we did this? Let's see what the question was. Total distance traveled by the car. Does anyone remember in the fall how we found total distance traveled? Didn't we do it with the little diagram? So what we did, we found the turnaround points, right? Do you know where the turnaround points are? They're at 1 and 3, right? And we found the position of the particle at time 0, time 1, time 3, and time 5, and just added up total distance traveled. Right? Well, the problem with this problem, and it wouldn't have been given to us in the fall, is I don't have a position function, right? Could I find it though now? Okay, so option 2. Option 2. You could do option 1. Same thing. And in fact, you'll see as I work it, we will end up going through the same complications. Good. I don't know if it's a lot more work or not. I think, in fact, I would say equivalent. It's about the same. I could find the position function. It would be t cubed. You help me. What was the middle piece? Minus 6t squared plus c, right? If I go find the position equation, it does have a plus c on it. If I were to find c, I know that at time 0, the position is 2, is that right?
Time 2, the position is 0.
Time 2, the position is 0. So I would plug in 2 cubed minus 24. 16.
Minus 2.
So negative 2. It's positive 2 and subtract over. Negative 2. Negative 2. Because it's positive, it's 2 plus c equals 0, and then you subtract the 2 over. Okay. Then I could find the position at time 0, the position at time 1, the position at time 3, and the position at time 5. Right? I find how far apart they are. Does this feel like the exact same computation we just did? Yes. The only difference is the 2 that's in there. So you can tell it's not really more work. It's just a different way to think of it. This is how we would have done it in the fall. It is the same thing. So anyway, you got options. Do I need to finish this? Plug in the 0, 1, 3, 5. Then you find the distance between each one and subtract, or then you add them all up. Yeah. I can't. You want me to? 1 minus 6. 5. 4. You do x at 5. Oh, okay. Make it go faster. 4, 2.
It's 28 before it's not going to be that mad.
Yeah, it was 28 before, so it's going to be 26. Right? It was 20 before, so it's going to be 18. Yep. Well, I looked at later because we already put it. Wait.
Oh, you cheat this.
I don't think it's 3.
Wait, what's the distance between here and here?
Okay.
That's what you do. I was just
Well, now you have more options. That's what you had to do in the fall. So now you have options. They both give you the same. Okay, part C. Find the average velocity. We are given velocity. How do we find average velocity?
The
Average value of the function. So I'm going to do the integral from 0 to 5 of the velocity function. What was that original? 3t squared minus 12t plus 9. When you answer one of these, write that down. Don't just skip to the answer. Because most of the time you get a point for that. There's a point right there. For setting that up, you get a point. So we want that setup point. So set it up at that point. There is no harm in stealing your work. Have we already plugged 5 into this in a previous part of this problem? We got 20. So the average velocity is 4 meters per second or whatever we have here. We don't know. So they'll give you points. Yeah. In fact, they tell you if you don't know how to do part A and part B, use part A, you go back to part A and put it up down. And that's okay. And I will grade that way. When I grade your AP test in here, I will grade it correctly. There will be times that I am unsure, and I will err on the side of not giving you points. You know, I don't know. But then some, and I'll tell you that. I'll say, maybe it might give you a point for this. You know, so things that are pretty gray area, you know, well, don't read that. This is a typical calculus student. I'm going to exceed. I got to do great. Yeah. So he's trying to find an area of the garden. He draws a picture. He does the integral to find the area. He could have done something. Call me Mr. Rigorous. And then his teacher's handing back his quiz from last week. The stack of papers.
Oh.
Let's look at this. The particle moves along the y-axis with velocity given by that function there. T greater than or equal to 0. Is this helpful? Do you feel like this is helping for your AP packet?
Very much.
See this problems? This is helping doing this. I was going to try to find my key to that last problem and see if it was a calculator problem or not on the real exam. Okay. Problem number 1. Was 1992 number 2. It's 1992 is tricky. It looks like they did not use a calculator on 92. It was back in 1992. They asked things a little differently then. Yep.
Back in the ancient times.
But they did do things a little differently on the AP exam. Back in the early 90s. I don't know. I don't know if they had like a 4-function calculator or not. I don't know. I need to look at that. Yeah. They had them, I think, 80s is when they started having graphic calculators, but I don't think they were using the AP exam. I'm guessing they just didn't let you use a graphing calculator. Like you might have been able to use a 4-function calculator, but not a graphing one. But I really don't know. That's why I think on that last one, I kind of feel like they might have had a 4-function calculator to do some of that mental math. I mean, I know you're expected to be able to do it, but
After the AP exam, did you just have like a use of that?
I don't know. A slide, I think you're talking about slides. I mean, ask is to help keep track of.
So if you like, say you like add a pretty eight, and then you like.
Yeah. It's just a. Cycle kinds of questions and log. Okay. In which direction is the particle moving at time t equals 1.5? How would you find that? Plug it in. Why? Y'all pay attention. Right? We just want to know, is that positive or negative? Correct? I think this was this one. Well, I'm about to. Yeah. It is a calculator problem. Now, you could do this without a calculator. This particular question, you just have to figure out which quadrant that's in, right? It wouldn't be that horrible. So, what is it, 1.67 or 1.167? Greater than 0. That's 20.
Oh. It's like memorize all.
Okay, so that's greater than 0. Why? Oh, sorry. Is the particle moving up or down? Up. Why? And I really labeled this incorrectly. Be careful about that. V of 1.5 is greater than 0. Don't call it V of t and put 1.5. Sorry about that. Part B. Find the acceleration of the particle at 1.5. So I need to do the derivative, right? That's good. That's easier. Antiderivative is possible. Have that t sitting in front. How do you do the derivative? Product rule. Left, d right, plus right, d left. And we're going to plug 1.5 into that. Now, that being said, if this is truly a calculator problem, this was from the 90s, calculators did different things. But if this is truly a calculator problem, complete and thorough calculator problem now, how would you do a derivative at 1.5? Use your ddx button, right? You know what I mean? Again, I think this one they had to work it out. Their calculators must have not done derivatives yet. But my dad took calculus. He saw what my calculator Okay, any questions about that one? Given that y of t is the position of the particle at time t and y of 0 is 3, find y of 2. What kind of question does that sound like? Initial condition, type problem. You have two options. You can, well, actually, you have three options, maybe. We could go back and actually find the function and then plug it. That's an option, right? Actually, anti-differentiate, use the initial condition to find c, and then go plug it in. That's option one. We could use f of b minus f of a equals the integral from a to b, that thing, or we could use a rearrangement of that thing. All of them will do and get the exact same thing. I'm going to use the one that I think is the most efficient, and that is we are trying to find y of 2. That equals y of 0 plus the integral from 0 to 2 of b of t dt. Everyone agree? So I think that's the slickest way to work it. All the others will work great too. To do the exact same thing as this written differently, y of 2 minus y of 0 equals the integral. It's the exact same thing. I think when they did this problem, I think they had to do the integration by hand. If this were on today's calculator problem, you type 0, which is 3, plus that integral in your calculator, you find the answer. Just because this integral can be done by hand and you are in the middle of an integration gateway where you need to practice that, I'm going to do this integral by hand. Why do I think it can be done by hand? How do I know that? What makes me think I can do it? T squared, what's the derivative of t squared? This looks like a classic U substitution problem, doesn't it? So U is t squared. Again, really, peeps. If this is really a calculator problem, you just use the calculator. But I just want to practice your. Marks okay? So good. This is 3 plus the integral from 0 to 4. Where in the world did I get 0 to 4 at? I changed the u values from 0 to 2 to 0 to 4. Because now they're u's, not x's. T times sine of u times 1 over 2t. T's cancel. The antiderivative of sine of u is negative cosine of u. Here's where you've got to have a calculator, and that's, I guess, their calculators must have done cosine values, but not integrals. Looking at the t, guessing from the t. Because here you would need to use a calculator, right? You can't find the cosine of 4. You can't find the cosine of 0, of which is 1. Anyway, so I just wanted, there is a function there. I just wanted to show you that integral. Again, if this is real AP problem, you're not doing that integral. You are typing that in the calculator and pushing it in. What do we get as the answer? so what did we do wrong there?
The negatives in, I don't know what I did. I just.
So,
I got
good.
the negative one got close to 0.
Turn it off. Check your test. Again, on the real life exam, if this question comes up, you're tapping that whole thing to calculate. I just practice taking rules. Why not? And find the total distance traveled. You know that, well, they must have been able to use a calculator on the integral here. So it looks like they even got to use calculators on it because that's not something I'm going to do by hand, right? Total distance traveled from 0 to 2. Type that in the calculator. That is a calculator question. Again, the only reason I did the other integral by hand was just for you and your practice. No, actually, yeah, okay. 1.73, is that right? I must be missing one. 1.173.